Good evening, good evening, good evening, good evening, friends. So, I hope I'm clearly audible and clearly visible. Chalo. So, let me just check that whether we are live or not. Yes, so we are live. So, good evening, everybody. Let me just see those comments. So, welcome. Today is 20th of April, and finally, we are starting with Lakshya Jee in English. Uh, to have a start, although when we were small, yeah, good evening. Now I can see those comments. So, Michelle, beta, good evening. Vipin, Saroj, good evening, beta. Anna, good evening. Uh, Mandal, good evening. Kulal, hello, beta. Hi, sir. Hi, Kulal. Sujoy, good evening, beta. Michelle, again, let's go. Parnika, I remember that name, Parnika. Hello, beta. Okay, you are Ekaf. Ekaf, I missed your actual name. Rama Gaurav, good evening. Parnika, good evening. Sayyad, good evening. Arpit Patel, good evening. Garima, Rani Ganesh. So, everybody who has joined over here, welcome, beta. 11th, whatever it was, however it was, let it be. It's done. Now we are starting a 12th, and journey of a thousand of mile starts with a single step. And today is that single step that we are taking. But you have to promise me one thing, guys. This is the first class and we'll be keeping it very easy. Actually, let me tell you one thing. Every class, if you just quantify and estimate the single class beta, every class of physics, chemistry, maths is nothing. Yes, all my YouTube people, hello Vikram, hello DX, this is the first class. So my batch students, I mean my JE warriors, the Lakshya Jee 2027 enrolled students, we will be definitely meeting regularly. Today, tomorrow also we'll be having our classes. Hey beta, the DPP, okay, this is the first page. So the DPP, the after the class you will be getting the DPP. Now let us quantify and decide the ground rules for my class beta. Hello Meghna, hello Pratoy Das. Beta, what does Pratoy means? Very different, very nice name. Ria, hello beta. Now the ground rule which we are setting from day one is, beta, no backlogs. Whatever I'm teaching over here, there may be two different category of students. Everybody has got same head. The only point of difference is how you are going to utilize and make use of this one head. Everybody has got one. Even I've got one. Now it depends upon the way you are going to write. Like for example, today's class we'll be starting with solution and colligative properties, the chapter for a CBSE class 12 student. It is a 5 to 6 marks chapter. Or in a JEE mains examination, you will definitely get one or maybe two questions from this chapter. One question you will get from this concentration term. So today we'll be starting with concentration term and we'll be dealing it from the basic. Even if you do not know anything about mole concepts and of class 11th, do not worry. I'll be taking it very slowly, because every day we'll be moving that step, and that foot we'll be keeping it so strong that you will say, we'll be starting the class although you know zero, we'll be doing an advanced question in the same class. So from zero to hero in the same class you can become for every topic. But the main point of difference is, the ground rule that I'm setting is, the notes that you are going to make beta, I am segregating you students in two halves. One student, some of the students have very sound writing per speed. The number of words that you can write per minute, let's say it is very sound. So definitely you can make the notes and at the same point of time be interactive also. Try to solve all of the questions. The calculator part you can keep a rough copy also, fair copy also. Fair copy you will be writing everything. The moment you feel, nahi sir, my inclination is my handwriting is not that. Now this is for those students whose handwriting are very fast, or rather I say optimum. So if they obviously can manage writing the questions also and writing the solutions also, then you can definitely do that. Don't make this judgment error that, sir, I will not write the question, I'll just solve the question. No, because for the single day, or maybe after a week, or maybe after 2 weeks, you may recollect that what the concept, what the question was asking. But actually this word problem becomes a huge obstacle once you revise your content after 2 months or after 3 months, or maybe after, let's say, we have finished in organic chemistry, and in your cumulative test solution and colligative property is coming, but you picked up your notes, but you cannot find, what was the question. So make this thing very sure that whenever you are writing, you should write the questions also. The complete question you have to write very properly. Sir, but my handwriting is very slow. Then how can my handwriting was also very slow? Every engineer is supposed to have a very bad and a slow handwriting. No worries. In that case, what you should do is use the technology, use the app feature. What is that app feature? After the class is done, you can always download the notes. As soon as the class is over, maybe you'll be having a following class after that. Like today you're just having chemistry class, but obviously regularly you'll be having 2 classes. So after that, what you should do is, after both the classes are finished, have your dinner, and post having your dinner, go back to your class notes with the PDF of the exact lecture notes. Leave space for writing questions and write the question as soon as possible. You know how it is going to help you. Right now I am teaching this, so these are my notes, not yours. You are just listening to it. Once I am not there, once I am shunted, but my notes are there with you and your copy is there with you, now you have to reproduce those notes by iterating them again and again. Maybe you have not written the question, so write down the question. Now you will be revising that notes, and then those notes will become yours. And the moment they are yours, beta, you will gradually, Taj Mahal was not built on a single day. You will gradually feel, sir, I am not even forgetting any concept, because you are regularly revising as soon as the class is over. But it is a very disciplined task, beta, not a crucial, not a difficult task, but a very monotonous task. So after each day your class is over, go to your family. Obviously the most beneficial factor of joining PW online batches is you can enjoy the comfort of your home. You do not have to drag your bikes and motorcycles and Activa to a distant places, so that it will kill your time also, it will kill the petrol also. It will be hazardous also, because you get to accompany so many people whom you can't restrict, you can't filter out that whatever the content they are feeding inside you. Because actually, before starting my class, let me just give you a single story. It is not my story. Yes, Ekaf, I know your real name is Michelle. So let me start with one story. I was just reading through some articles, and I guess the day before yesterday I read that story, and it moved me like anything. There were 2 boys. One boy was very slim trim, very small, very short. One boy was huge like me. They have gone out for a swimming, and the huge guy was actually drowning. And you know what happened? The guy, the thinner guy, the shorter guy, which was having no power, that guy saved the fatter one. And icing on the cake was, the slimmer guy do not even know how to swim. Yes, even I was having a feeling that it's a false story, but actually it was a true story. And you know what made the small little guy save the fatter and huge guy from drowning? Because there was nobody around him who was telling the slimmer and the shorter guy that you can't do it. Actually, if nobody is there to tell you that you can't do it, it will be done. Whatever is the syllabus, you have planned to crack it, and you will crack it, I'm telling you. But you have to filter out all the negativities, filter out them from your life, and only allow positivity. Now, not false hopes. So how those hopes can become actually true? By religiously just doing each class, which is no big deal. But yes, revising those class are not important, they are very very important. So with that, with the statement, with the proverb from, I guess, class 6th, class 7th, journey of 1,000 miles starts with a single step. And this is our single step with which we are starting, because God help those who help themselves, and all of us are here because we are trying to help ourselves. So all my YouTube students, all the students who have joined us in the through the app, Niharika, good evening. Karthik, good evening. Varsha, hello. So with that, we are starting with the first chapter, the physical chemistry, the first chapter of NCERT, which is solution and colligative property. Although initially NCERT had solid state, but because solid state is now just a syllabus for JEE Advanced, so we'll be definitely starting with solution and colligative properties, where we'll be dealing with the definition of solutions, and post that we'll be doing the concentration terms. So everybody ready with their pen and copy? Sir, you are very engaging. Thank you, beta. But you also have to engage yourself. Lamjing, you need to promise that you will be making your notes very beautifully. Whenever you're feeling, no, sir, I'm taking time to solve. I want to recollect all the concepts that is thrown at you by me. At that point of time, jump to your rough copy and leave that page of your fair copy. Always sit with 2 copies, and once we are done with the class, once you are done with all the classes for the day, have your dinner, and post dinner go back to these PDFs. These PDFs will be uploaded to PW app. These PDFs are not important, they are very 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 important. And with that note, let us start the chapter where we'll be studying about solutions and colligative properties. So yeah, beginning with the basic definition, sir. We know this from class 9th. What do we know? What are solutions? Actually, solutions are mixture of two or more components. If those components have different physical state when they are mixed, then that becomes a heterogeneous solution, heterogeneous mixture. And once you have mixed more than 2 components into a mixture, that mixture starts to be termed as a homogeneous solution once the physical state of all the components becomes same. So the basic definition, which will definitely be helping you for your class 12 boards also. What are solutions? A solution is nothing but a homogeneous mixture of 2 or more non-reacting substance. Now some people, I want you to write this definition in your copy, because this is also important for your class 12 board examination. A 1-mark question for a homogeneous solution. You have to take those components which are not reacting with each other, so they have to be a non-reacting components. Now in our mathematical calculation, because from solution chapter, NTA, JEE Advanced, your class 12 boards, everybody throws you questions around homogeneous solution. So again, what are these homogeneous solutions? Nothing, a solution which is uniform throughout. Sir, what does uniform throughout mean? So let me just take the help of this empty slide. Yeah, so what is this homogeneity, sir? This homogeneity is nothing, beta. Actually, let's say if I have this water, let's say I have water with me. Okay, sir. Now you tell me, in this water, let's say I have added 2 to 3 drops of, let's say 4 drops of lemon. Now this is lemon mixed with water. Let's say I was feeling something, I wanted something very tasty to be consumed. So let's say I have added few grams of sugar also into it. So let's say I have used some sugar, and let's say I have added some few chaat masala also into it. So let's say I'm adding chaat masala also. So that will actually give me good taste also. So this is what I have prepared. So these chaat masala was a solid, These sugar components were also solid. The drops of lemon that I have introduced are liquid, and they have gone into water, which is also a liquid, and definitely they have formed a lemonade. Now this lemonade is my solution, which is obviously having more than one components. And what is the physical state of this component? The physical state of this mixture is obviously liquid, so this becomes a liquid solution. Now the point that I'm making is you may have more than one components, and then the solution, if I had only two components, then the solution will be termed as a binary solution. If I had three components, array sir, this is easy, then it is called as a ternary or a tertiary solution. If I'm adding four components, then it becomes a quaternary solution. But for our understanding, we are only focused on binary solution. We are only asked questions around binary solution. I hope everybody, I mean, very easy. I think we should write notes from these slides, Geeta. Ha beta. Actually, if you are comfortable in writing notes at this point of time, so you should definitely start writing, else I will also be giving these notes to you. So what my point is, whatever content you feel that you should write right now, then that content you should definitely write. Whatever content I want, that it should be definitely there in your notes while reading the class also. At that point of time, I'll be telling you, beta, note it down. So ultimately, the first thing, as of now, if you have not written anything, do not worry, because everything is just a beginning of the synchronization that we are going to attempt in this class. So do not worry. Just sit back and listen to it. Whatever you feel you should make note of, definitely you can with the PDF. Once the class is over, you can go back and write properly using the PDF. But in the class, I want your full attention to be there in order to absorb the concept, because we are starting with zero, actually zero. If you know nothing, I'll be starting from zero, but in the end of the class, I promise we'll be doing JEE advanced question. Chalo. So what type of solution we are focused in, sir? We are focused in only binary solution, because we to us NTA, JEE Advanced and NCRT generally frame questions around a binary solution. So we now know what is a solution. A solution is a homogeneous mixture. Now this is the slide. I want everybody to take their copy and write. Now what is a solution actually? So please note it down. Now solution is a mixture of components. The components, one is solute, another is solvent. Now how can I define a solvent? So let me start defining the solvent, and I want you, every one of you, to at least write it very properly. So types of solution in terms of nature of solute and solvent. But sir, what are solute and solvent? So you can definitely write that solution is a mixture of solute and solvent, where solvent, what is the definition of solvent? The basic definition of solvent is which decides the physical state of solution. Like in the previous example, water was in liquid state, and after addition of solute, now it may be solid, it may be liquid, it may be gaseous also, but if the whatever the state of the solution is, it will be decided by one of the component. The component which decides the state of the solution is known as solvent. And from our foundational classes, from class 7th, class 8th, you will be knowing this, that generally that component is termed as solvent, which is present in larger quantity. But actually this definition is not always valid. That's why I have placed this definition at the bottom. So actually what is a solvent? Which is the physical state of solution. But yes, sometimes we can be shameless because actually this is being shameless. So sometimes being shameless, we can also say that solvent is that component of a solution which is present in a larger quantity. And what about solute? In a solution, apart from solvent, whatever components you have, those components are termed as solute. It may be one, it may obviously be more than one. I hope we are clear till this, guys. Shall I move forward? I hope everybody has written this. Now, chalo. Shall I move forward? Sir, I'm a dropper. I'll be free in morning. I haven't studied 11th. What should I do? Daniel beta, I answered that in the beginning only. Join us right now. Why? Because this is the best time from where we should start. Chalo, everybody is clear. Moving to the chalo, fatavat, be very quick and answer this. I'll be using this poll. So this is just a you just have to identify solute and solvent. Okay, I'm not using a poll because I do not have any option. So fatavat, I want answer quick. Sugar and water are mixed together to form a liquid solution. Here, what is solute and what is solvent? How can you identify that? Sir, the solution that we have over here is in liquid state, and sugar is one component, water is another component. Sugar, everybody knows, sir, sugar is present in solid state at room temperature. Water is present in liquid state at room temperature. Liquid solution, that is, once you add sugar and water, it is also in liquid state. So obviously water becomes your solvent because the state of the solution is decided by this component which is in liquid state. So obviously this is my solvent, and this is definitely, this makes sugar as solute. I hope easy peasy. Perfect. Do not have to write this. Another question, guys. Yeah, so I have liquid A and I have liquid B. They are mixed together and a liquid solution is formed. Now you have to identify which one is solvent. Now physical state definition will not help you. Why? Because sir, solution is also liquid, the components are also in liquid state. Yeah, Ankit, perfect. Yashwit, perfect. Janavi, perfect. Ready, perfect. Everybody is right. Perfect, guys. So I love this. You are all actually focusing. Perfect, guys. But maintain this. Today is the first class. You have to maintain this. Perfect. So in Ashok Kumar from YouTube is also okay. So we have our YouTube people also. Rohan is saying, please talk in Hindi. Rohan, kindly go and check what is the name of the YouTube channel you have joined. It's PWJ English, beta. We are supposed to speak in English. Chalo. So actually, yeah, perfect. Niharika Kapoor, Sri Lata, Harshini, Yashwit, everybody is correct. Now, actually, here B is solvent. Why? Because once both of them has same physical state, then obviously I've written that also, that component which is in large amount and the component which is smaller amount will become your solute. Sir, this is also very easy peasy. I hope everybody is clear with this also. Perfect. Next question. In fact, I am making another question, so you have to answer this one while I am giving you another question also. Let's say I have 40, first you answer that one and then this one. 40 ml H2SO4 dissolved in 100 ml water. But this is first part, and the second part which I am giving you here. If I have not 40 ml but 110 ml H2SO4 in 100 ml water. So I need solute and solvent in all the three cases. First, talking about this one. So we have to identify solvent and solute in a syrup having 60 gram sugar in 40 gram water. Now obviously we can see amount of water is less, but amount of sugar is definitely more. But once you add sugar and water, what can you say about the state? Sir, the state of solution will be in liquid state. Yes, it will be a highly concentrated solution. It will be highly concentrated. That's why I'm using the word syrup. So it will be highly concentrated. Agreed. But sir, you have already defined it with the definition. Among sugar and water, water is present in liquid state and sugar is present in solid state. So that component is actually termed as a solvent, which decides the state of the solution. The state of the solution is liquid, although it is highly concentrated. Therefore, here also water will definitely be the solvent, while sugar, although present in more amount, but it will be acting as a solute. So actually, I mean, here in the categorization of solute and solvent, that's why I use the term you have to be shameless at times. You tell me, although it is not written anywhere. Now these are some mischievous things from chemistry, although this is not written anywhere. Amount of water, but you have written that definition. We'll be coming to another example. That's why I'm making that picture around the explanation. Here, definitely, by mixing sugar and water, the solution that we are obtaining is present in liquid state. So obviously, water will be the solvent. But here, H2SO4 is 40 ml, water is 100 ml. Sir, solution is liquid solution. Here also solution is liquid solution. So we will definitely say, because both components are liquid, hence because this is in lesser amount, so I'm saying this is solute. And because water is in larger amount, so it is solvent. We have no problem in saying this, but here also, if you have taken 110 ml of H2SO4, still I'm saying it is solute beta, and still I'm saying this is solvent beta. Now here we have to be shameless in saying this. Why? Although not written anywhere. You tell me, if I have a glass of water and by mistake that 40 ml H2SO4 mixed with 100 ml of solution goes to my skin, I'll be okay. Yes, I have to wash my hand because acidic water getting into your skin will create that itchiness. But sir, if the solution will be having 110 ml of H2SO4, if that solution has poured into our skin, it will be like the skin will be, maybe it can get burnt. So that's why I'm saying the solute component of a solution actually decides the nature of the solution. So if you say H2SO4 is the solvent, then you tell me who is actually deciding the reactivity of that particular solution, H2SO4 or water? H2SO4. Who decides the reactivity of a solution? So the solute. If you add sugar into your water, it will become sweet. If you add salt in your water, it will become sour. So actually, who is deciding the property of a solution? Solvent or solute? Solute. Who is deciding the property of a solution? Solvent or solute? Solute. So that's why sometimes you have to be shameless. Although I am telling you, it will be a controversial point of thing. That's why nobody touches it. Nowhere it is written that a solute decides the property of a solution. Therefore, even if you add more amount, still it should be termed as a solute, and that should be termed as solvent, because H2SO4 is deciding the property of the solution. I hope. Acha, chalo, Teja is saying, sir, explain example 2 again. I'm saying this is a dilute solution. Agreed. You, beta, JEE asks you to be very smart. You tell me, if I have water and you are bathing with that water, good to go. You will be having no skin problem. If you have water and diluted with acid, so this mixture, this solution, what will you name this solution? I will name this as a dilute solution. Dilute H2SO4 solution. In fact, dilute H2SO4 aqueous solution. Agreed? Okay. Now, if I'm asking you to name this solution, I mean generally, what will you name? Sir, it is also aqueous solution, but highly concentrated. Highly concentrated sulfuric acid aqueous solution. Maybe you will not write aqueous, but because you are writing solution, that means H2SO4 is definitely mixed with water also. Else it will be pure H2SO4. So actually, although it is not written, yes, Sujit. So it is general property that solutes decide the nature of the solution. Although, yes, Sujit, perfectly correct. But it is not written anywhere. So actually, solute decides the property of a solution. And therefore, to this solution also, I'll say this is my solute and this is my solvent, because this is deciding the property of my solution. Yes, else you tell me, na, Harshini, Ridisha, you guys tell me, how will you make a supersaturated solution? Again, you are saying solution. So you will say you have to superly increase the concentration of solute, na. How are you going to produce a supersaturated solution? You tell me. Ultimately, you have to keep on increasing the amount of what? Solute. So I hope that common sense will be telling you there is some difference with the definitions. And yes, such mischievous things always is done. You do not have to go to Morrison and Boyd for some good questions. This we can obviously explore using an NCERT only. So we are just playing with the phenomena of criticizing it. What definition you have written? You have written a wrong definition. So that is the point I'm making. But still, the scientist community, they don't generalize these definitions, because obviously then you may find some traps around it. So that's why there are some things that you have to be in sync with. Sync from where? Sync from within. So that is what it says. So feeling, I'm getting a feeling that it is the solute, and definitely this is the solute, and that becomes your solvent. I hope nobody is going to ask you this, but I'm just building a temperament of how you should think and challenge whatever is written. I hope everybody is clear with this. Sir, may I ask you which date Arjuna will be? Soon enough, beta. And for Arjuna, Nick, for Arjuna, JEE in English, we'll be coming up with very good surprises also. But yes, I'll be communicating that in YouTube, but this is the time we are there in our batch. So all the YouTube people kindly have an environment, a feeling of what we are actually doing inside our batches. So don't worry, but please focus on the content over here, not anywhere else. Chalo, moving to I hope everybody is clear with us. Now, coming back to the basics of NCERT, the important table where we are segregating the types of solution. The types of solutions can be on the basis of physical state of solute and solvent as well. What are the very famous three types of solutions? Are gaseous solutions. Gaseous solutions are those. Don't write it at this point of time. I would rather suggest leave a complete page, but you have to draw this table, a very important table directly from NCERT. But I want you to actually focus over here, not on your completing your notes. That you can obviously do later with the help of these slides. But right now, I do not want you to write this. Just listen to me. So when you have gas acting as solvent, so the physical state of solution will also be gaseous. What are the basic examples? Like if I have gas dissolved in a gas, the very famous example is oxygen dissolved in nitrogen, because in atmosphere, what is the percentage of nitrogen? Nitrogen percentage is somewhere around 78%. So obviously nitrogen becomes your solvent and oxygen gas becomes your solute. I hope everybody is clear with this. I do not want you to write at this point of time. Sir, Hindi में भी समझा दो. Pradeep beta, I hope you can I hope Pradeep, because you are there in the batch, so definitely you can understand that the reason we are here is because the mode of communication we are keeping is strictly English. Beta, have that compassion. What compassion? Beta, there are many students like you. I mean, although you are joined over here, but still you are saying Hindi mein samjha do. That means you must have joined because you want to be away from the noise, from the huge chaos which obviously is there in English channel, because they are crowded. I agree. And this is the initiative that we have taken, that so that we can segregate the crowd who are more serious also and who are more eager also to communicate and study only in English. So that is the reason we are doing over here. So I hope Pradeep you can understand beta. Chalo. So Suraj is saying 76%. Beta, whatever it may be, Suraj is saying 46%. Bro, this is Lakshya. Okay, Ekav is answering. Chalo. So actually my point is, gas dissolved in a gas. Now who becomes solute, which is in lesser amount? Who becomes solvent, which is in larger amount? Sir, live is not coming in PW app. Nahin beta, it is coming in PW app also. And Sanjay, we are, because this is the first class, so we are coming at YouTube also. Chalo. Sir, when a liquid is dissolved in a gaseous solvent, what is the famous example? Chloroform mixed with nitrogen gas. Chloroform, you must have seen old Hindi Bollywood pictures. The heroine used to be kidnapped by the villain. The villain used to put some liquid from a dark colored bottle onto the handkerchief and and bring the handkerchief in front of the nose of heroine, and the kidnapping finally takes place. Although it's a cliche, I'm very sorry I'm using that example, but it always comes to my mind whenever I see chloroform, which is a liquid mixed with nitrogen, and what is formed? Phosgene, and that phosgene is actually very poisonous, which ultimately creates that dizziness, and that's why heroin goes off. So a very famous example. I hope everybody is comfortable with this. Now, when a solid dissolved in gas, what is the famous example? Camphor. Camphor dissolved in nitrogen gas, because in air, what is the famous solvent? A nitrogen gas. Coming to liquid solutions, again liquid solutions will be those, okay, when solvent will be liquid, I'm sorry, this will be liquid. When solvent will be liquid, then then you will get a liquid solution. What can be solute? Any physical state can be a solute. When a gas dissolved in liquid, the famous example, oxygen gas dissolved in water. Liquid dissolved in a liquid, when ethanol dissolved in water, you must have seen again Bollywood films, water having ethanol, liquor. So ethanol, which is a liquid in smaller quantity mixed with water as a solvent. Solid dissolved in a liquid. What solid? Famous glucose C6H12O6 solid dissolved in water is an example of a liquid solution. What type of liquid solution? Solid in liquid solution. Last is solid solutions. Obviously, when the physical state is solid. I am sorry, I have this error. So once you are writing, you can completely make your notes properly. So gas and solid, what is the example? The solution of hydrogen in palladium. From class 10th only you know this. Remember this, let me write that example also for you. It is a famous example. Let me write that example for you, but for that I need a slide. So let me borrow the slide. Chalo. So you must be remembering this, that I have alkene or alkyne, any unsaturated hydrocarbon. So I just need a unsaturated hydrocarbon. This unsaturated hydrocarbon reacts with hydrogen in presence of nickel solid, or maybe platinum solid, or maybe palladium solid at elevated temperatures. Actually what happens is these hydrogen gas get adsorbed on the surface of these solid catalyst. So these are my solid catalyst, and once hydrogen gas is adsorbed, they act as a catalyst, and the reaction takes place, which leads to the formation of a saturated hydrocarbon. So here what is acting as a solvent, what is present in larger amount? Sir, this solid. What is present in a smaller amount? These gases. So this gas in solid forms a solid solution. I hope everybody remember this example, a very famous example rather. Now solid, liquid in solid solution, amalgam of mercury with sodium. Everybody must have read had that caramel, the chocolate, eclairs. Everybody must have seen the ad also. Eclairs, itni chocolatey kyun hai? Remember the melody, why melody is so chocolatey? I hope everybody remember that. So what is that? What is present over there? Let's say I have a solid, and in that solid we have small amount of liquid. A very famous example of alloy also. Now what type of alloy it is actually? Generally you have a sodium closure and mercury is fixed into it, and whenever mercury is mixed as a metal to another solid metal, the composition, the complete mixture, the complete solution is given a name of amalgam. So I hope you can remember that also. So this is your amalgam. So whenever you have this word amalgam, you can rest assured that one of the metal is definitely mercury. Another example in solid is solid solution. All the alloys that you have, all the alloys like brass, bronze, all the alloys that we have are actually example of solution having solid solute dissolved in a solid solvent. One of the famous example is copper dissolved in gold. So actually gold, whatever gold we wear, that gold is not workable. In order to make that gold workable, in order to allow that gold to be having some different shapes, in order to make it workable, to be made designs out of your gold jewelry, it has to be added with some impurities. That's why the term 24 karat. What does 24 karat gold mean? That all the 24 parts is gold only. And generally the jewelry that you have is not 24 karat, it is rather 22 carats, because two parts of some other alloy, some other metal like bronze, copper is mixed, so that the gold becomes workable. I hope everybody is comfortable with that. Chalo. Sir, but it's concentrated at point. Can it still be considered as a solution? हाँ बेटा, Vetrimaran, you tell me how you are supposed to form a supersaturated solution. Ultimately, that solution will be having lesser solvent and more solute. And you are saying, na, more solute. So ultimately, that component has to be named solute only, na? Then only its concentration will become so high that the solution can be termed as a supersaturated solution. I hope I'm making you understand that part. 24 karat only in gold barite. Yes, beta. 24 karat is just a Michel. 24 karat is just a nomenclature used for gold industries only, because they have 24 parts of gold, that is pure gold, and whatever amount it may be, let's say 100 gram, divide it into 24 parts. So out of those 24 parts having 100 gram of gold, you put 2 parts in your pocket and add 2 parts of some other impurity. That will make the complete gold ornament workable, so that you can make designs out of it. That is a physical constraint of gold, that it can't be worked properly. That's why whenever you have a beautiful jewelry which has some designs, it can't be 24 karat. It has to be having some lesser percentage of gold in it. Then also it can become workable, so that you can craft out designs out of your jewelry. So I hope, nahi beta, not in coins. Somebody is buying gold, then for investment purpose, then they can buy pure gold, but that pure gold is not having any designs. So that is therefore just a bar. So you just keep that bar and keep it in your trunk, and your generations to come will open it and they say, grandfather has left us so much of gold. So, but that you cannot, if you wear that bar here, it won't look beautiful now. So that ways. Chalo. So that is an industrial reason why gold essentially per se is estimated as carats, not in general. So that is a financial aspect to it, not scientific. Chalo. Scientific is just that pure gold is not workable. Chalo. I hope everybody is clear now. Now we are coming to whatever discussion we had. It is just It was just existing because it is our first class, and I don't want to make it from the first class only. I don't want the first slide to be having the questions which will rather haunt you, because I actually, you can make your learning quite fun, beta. So after the fun part that we have, moving to the important part, the concentration terms. As we were discussing, sir, that means, so whenever you form a solution, ultimately it depends on what amount of solute is added to what amount of solvent. I hope everybody is clear with this. Now, sir, but we will have so many variations. So how to estimate, how to quantify? In order to quantify the community of chemistry and all the communities which use solution concentrations as their benchmark for their operational functionalities, so rather they have defined some concentration terms. In order to define those concentration terms for our mathematical ease, I am defining one thing. What? Whenever I will be using solvent, I will be marking it as 1. I mean, weight of solvent W1, mass of solvent W1, molar mass of solvent capital M1, density of solvent D1. I hope I'm making sense over here. Whenever we are talking of the solute component of a solution, we will refer it as 2. I hope everybody is clear with me. And obviously, if I have a solution, so I'll be writing solution only. Solution as in I'll be writing like this. So ultimately, coming to the most famous, sir, you can send me numbers. Sir, okay. For all those students who are having any app related or admission related problems, beta, kindly go to PW app. I'm talking to my YouTube students over here because I can see few comments regarding the admission process. So beta, go to PW app, directly go to the contact section. You will be getting a I guess on the right side, right bottom side, you will be getting a chat option. So once you put in your query, everything will be resolved ASAP. Don't worry. Chalo. So moving to the concentration terms, as I said, I am considering that you know nothing from class 11th. Don't worry. Now take out your copy and pen and start writing the first concentration term. The first concentration term is percentage composition. Take out your pen and copy and start writing. So first percentage composition. Percentage composition can be defined in 3 parts. Part 1 is mass by mass percent. How is it defined? Mass of solute upon mass of solution into 100. But as we have segregated some nomenclatures for us, so mass of solute I'll be writing as W2 because solute. Mass of solution I'll be writing as W solution. Into 100. Volume by volume percentages, sir, volume of solute upon volume of solution into 100. Now I am not bothered with unit because everybody knows that if I'm putting this in gram, then this should also be in gram. If this in kg, and this should also be in kg. That means because these are same units, so we'll be keeping the units also same. So gram upon gram, kg upon kg will be getting cancelled. Similarly, here I'm using volume in ml, so here also I'll use an ml. If here in the numerator I'm using in liters, so in denominator also I'll be using in liters. But here you have to keep in mind, most of the students don't remember this inside their examination, so please note it really properly. Mass by volume percentage, what is it? Mass of solute as in weight of solute as in 2 in gram, so write gram upon volume of solution in ml into 100. Now if the question is supplying mass in milligram or kg, convert it into gram. If question is mentioning volume of solution in liter or whatever, convert it into ml. And one thing everybody should know, density of water is general density, I mean at 4 degrees Celsius, it is 1 gram per ml or 1 gram per cc. So obviously you should know that 1 ml is nothing but 1 cubic centimeter, or simply cc. I hope everybody is comfortable with these conversions, because I am assuming you know nothing from class 11th. I hope we are clear till this. So thank you so much for starting an English batch. Ready? Pleasure is always ours, beta, but we want your result to be blossoming like anything. So as I said, no class is big deal, but yes, once the structure of the class is getting stacking one after another, so you have to keep in mind that you have to keep revising properly. So I hope everybody has written this. Now chalo, shall I move forward? Now beta, I am just making you write these definitions because we have to come to these definitions again and again. First of all, what I'll be doing is we'll be writing all the definitions, and after writing all the definitions, we'll be doing all the possible permutation and combination around the numericals. And we'll be completing those numericals here in the class only. Today also, tomorrow also, we'll be practicing them like anything, because advanced also ask them, mains also ask them, and it becomes a headache for students. So I don't want it to be your headache, that therefore I'll be discussing all the possibilities of the questions, but first we'll be dealing with all the definitions, and I want you to keep iterating these definitions from your mouth also, so that it may come into your head. Iterating, repeating over and over again with mouth is very important. How have you learned those songs, which I hope you, all of you will be definitely be knowing few songs. So have you mugged up those songs by writing and reading them like this? No, you have just iterated them from mouth like anything, and in your subconscious mind, they just have gone inside your head. That is what I'm trying to tell you, that keep iterating, keep repeating, keep on reading these formulas. So what is mass by mass percent? Weight of solute upon weight of solution. Volume by volume, volume of solute upon volume of solution. Mass by volume, mass of solute upon volume of solution. So in the denominator, we generally signify the solution, and in the numerator we signify the property of a solute. I hope everybody is clear with this. Sir, हाँ beta, is ml and gram fixed only for mass by volume? Yes, Chaudhary ji, Ashmita Chaudhary. Yes beta, it is only defined over here. Here you can use any unit, but whatever unit you are using in the numerator, you will use the same unit in the denominator. That's then only it will be getting cancelled, right? I hope we are clear till this. Chalo, moving to the next one. Sir, this is the second concentration terms, parts per million. Whenever we have a very dilute solution, that means, sir, amount of solute is very, very negligible. Then what concentration term is implied? Parts per million, because percentage is per 100 of solution what solute is present. Million is 10 lakh rupees. So 10 lakh rupees is 10 raised to the power 6. And you can have same scenario. So don't write it, just leave space in your class notes. Parts per million can also be defined as mass by mass, volume by volume, and mass by volume. I'm just mentioning this again, which is weight of solute in gram upon volume of solution in ml, but into 10 raised to the power 6. That means 1 million, that is 10 lakh of rupees. I hope everybody is clear. 10 lakh is 10 raised to the power 6. Sometimes, although not asked by, not much used by NTA, so I'm not writing it also. Parts per billion. So billion is 10 raised to the power 9. So you do not have to write it. Just I'm using it so that for some there may be some reference books where parts per billion is also given. But in general, parts per billion in practical life also it is not much of use. Chalo. Moving to the next concentration term. So next concentration term is, please refresh your notes. Sir, why ppm is used? Beta, for dilute solution. Michelle, for dilute solution. For example, let's say there's a factory. How it is industrially used? Let's say you have a factory, and let's say some government guys are after that factory. So they want the factory to pay money to the government organization. So what they'll do is they go to the pond area, the water body inside the around the factory, and in the water body the waste of the industries are generally disposed. So those water waste are, the sample is taken and it is sent to a headquarter having forensic team. So like for example, fluorine, if the fluorine content is present in, let's say, 1 million of solution parts is having 29 or 30 parts of fluorine, then also it is quite toxic for humans and for animals to consume. So in certain cases, 10 lakh parts of solution having 30-40 parts of solute can also become poisonous. So for those cases, for such dilute cases also, we need certain concentration terms, and that's why ppms are generally required. But all the industrial forensic department uses that ppm. I hope we are clear with this. Sir, in exams they'll directly ask to find ppm, or we have to assume? Nahi beta, nahi beta. In exams how the questions are framed, we'll be talking about that. I'm just trying to make you write all the concentration terms definitions first, so that you can come to these definitions again and again. How we'll be coming to them? By doing n number of questions from them. So n number of questions we'll be doing, but which formula we have to use in order to learn that formula, you have to again come back to your notes. So these formulas you will be forced to revise again and again. That's why I'm making you write the formulas first, and later we'll be framing questions around them. I hope we are clear. I hope the task is also clear. Sir, their concentration terms are concentrated solute. Is there concentration terms for concentrate? Nahi beta, no constant. See, how solute can be concentrated? Solution can be concentrated. Solution can be dilute. Solution can be concentrated. How? When solute is less, solution is dilute. When percentage of solute increases, when you add more solute, then the solution becomes concentrated. Solute per se can't be concentrated. It's the solution that becomes concentrated or less concentrated or super concentrated. For example, you are drinking mango shake. The summers has already come. So let's say you are adding mangoes to milk. You may use water also. Let's say you are adding more mangoes into your milk and then shaking it. The mango shake becomes highly concentrated. It will become highly thick. So that solution is now concentrated. So solution can become concentrated or dilute, not the other way around. Solute can't be concentrated. I hope Garima, we are clear with this. Garima, chalo. So next concentration term is mole fraction. I hope you have started writing it. Now mole fraction is represented with a capital X. Technically it is termed as a chi, but I will rather say X only. Why doing that? No flaunting of extra English over here. We are not Shashi Tharoors over here. Our communication of English is only to that extent so that we can be understandable to each other. We know nobody over here is euphemistically active as per communication is concerned. So we are not Shashi Tharoors over here. We are engineers over here. So but yes, communication should be English and we are quite easily doing it. Chalo. So mole fraction, again we are only talking of binary solutions. So mole fraction of solute, so solute, therefore X2. As the name suggests, mole fraction is nothing but number of moles of solute upon number of moles of solution. Solution is nothing but mixture of solute and solvent. So number of moles of solution will be N1 plus N2, where N1 is number of moles of solvent. So mole fraction of solvent will be number of moles of solvent, which is N1 upon N1 plus N2. So if you add mole fraction of solute and solvent for a binary solution, sir, we can clearly see LCM will be N1 plus N2. Numerator will also be N1 plus N2. So mole fraction of solute and solvent for a binary solution is, now this is a term you will find very rarely in chemistry, is always. In chemistry, always is never used. I mean, it is very rare to see always, but here I'm writing. So make note of this always. So mole fraction of solute and solvent, the summation is always unity. You can obviously see this. I hope everybody has written it. Kindly confirm. Sir, please explain. What explain, beta? Mole fraction is nothing but mole fraction of solute will be number of moles of solute. Mole fraction of solvent will be number of moles of solvent with respect to what? With respect to solution. So mole fraction of solution is mole fraction of solute. Number of moles of solution is number of moles of solute plus number of moles of solvent. So x2 is n2 upon n1 plus n2. x1 is n1. Acha, I'm sorry. This is n1 beta. There's a misprint. I hope everybody can correct it. I'm sorry. That was a misprint. Devil, Ritvik, Roshni. Beta. Thank you. I have corrected it. I hope everybody can see this. Michelle. Perfect. Sayyad. I hope everybody is clear with this now. Shall we move ahead? Chalo. By the time, let me pour some more water. Niharika, everybody is clear now? Chalo. Yoganan is still saying clear. Thank you. Okay. Chalo. So I'm again explaining this because I guess we had a printing mistake over here. So I'm again explaining this. Mole fraction of solute, which is represented as x2, as the name suggests, because it is saying solute. So I will take number of moles of solute upon total moles. Total moles is solvent plus solute. And mole fraction of solvent will be x1, chi1, number of moles of solvent upon total moles. So n1 plus n2. If you add mole fraction of solute and solvent, obviously it will always be coming out to be unity. I hope with that printing mistake, everybody is clear now. Chalo. Moving to ultimately, we are just moving to the questions. I'll be just using few definitions more, but before moving, let us do this. Sir will be doing numericals today. Yes, beta, today only. We have I'll be extending this class today. We'll close this class somewhere around 8. So because this is the first class and today you are not having any more classes. Today you are just having one class. So I'm extending it because we are having one class. You are supposed to at least read 3 hours per day. To 1.5 hours per lecture. So because we are not having the second class today, so I'll be taking for another 1 hour. So yes, we are going to practice questions also. That's why I've taken this profit, this pleasure of making you write the formulas first and later discussing and practicing questions around it, so that you may have to turn your pages to see and read those formula, so that once this class is over, most of you will be remembering the formulas also that we have written. So that is my purpose of using this extended class. Nahi beta, no physics today, Michelle. You'll be having physics tomorrow. From tomorrow, we'll be having 2 classes. Today, because this is the first day, so we wanted to keep it light. So today, we'll be just having chemistry. Okay? Good. When will Ramya, when will Arjuna Jee start? As I already answered, beta, soon enough. Don't worry. Chalo. I need answer, guys. Fatafat. Quick. I need answer, and I am starting this poll also. Chalo, I need answer for this question. The basic formula which we have read, you have to use that formula and give me the answer. Chalo. Mole fraction of NaCl in solution containing 1 mole of NaCl in 100 gram. In 100 gram of water. Very easy. You just have to be quick with your calculation, guys. Garima, Kevin are saying option B. Okay, we'll check beta. Beta, first point is writing what is given. Second is using the proper set of calculation. Suraj, it's 100 gram. Yes. Shivam, it's 100 gram. It's sorry, it's 1000 gram. I'm sorry. It's 1000 gram. 1000 gram of water. Uh, Kabil, Kabileshwaran, Roshni is saying 1, Bilal is saying B, Michelle, yeah, it is 1000 gram. 1000 gram. नहीं, not 1 upon 1000 beta. 1000 gram. Come on yaar, it is written. It is written, my friends. Chalo. Let me. Acha, poll is ended. So let us see who. Okay, so we have 28% of the students only. That means, beta, please be very much attentive with your calculations. Yeah, so YouTube people are right. Batch people, 28% of the students are only right. Let me check the leaderboard. Rishikesha. Okay, perfect. Okay, I'll be browsing this later. So I have my leaderboard with me. Chalo. Let me check somebody. Okay, I am. Sir, for solute, it should be x1. That I have already considered beta. Chalo. So let me put this. Hey, how to put this off? Okay, gone. Okay. I was using these polls for the first time. Chalo. So I was also very much interested how to do it. Chalo. Let us solve. Sir, NaCl is solute. So this is 2. Water is solvent. So this is 1 for me. For the case of simplicity of writing values. How to vote in poll, beta? The poll will be coming in your app na, so you have to use the poll and then select the option. If you're using it through app, it will be definitely there. If not, then kindly after the class go to the technical section and in the PW app, and definitely now the tech team will be helping you if poll is not visible at your system. So after the class, please go back to the chat section. They'll be definitely helping you if you are not finding the poll. Chalo. Now, solute. Sir, mole fraction of solute. That means we have to find chi2. Number of moles of NaCl is 1. That means N2 is 1. What about N1? N1 is number of moles of solvent, which is water. So number of moles, what is the formula of number of moles? Weight of solute in gram upon molar mass of solute. Now to molar mass, I'll be writing it as mm. So molar mass of, because I am calculating it for solvent, so I beg your pardon. Number of moles of solvent will be weight of solvent in gram upon molar mass of solvent. So what is weight of solvent of what is weight of solvent given? 1000 gram. What is molar mass of water? Sir, 18 gram. So this becomes number of moles of water. Now, this is a very crucial data beta because because this is used so many times that I advise you should learn this also. This is approximately 55.55 moles. So these are the number of moles present in 1 kg of water. Even if in the question it will be given 1000 ml of water, then also it will be no different. Why? Because water is the only solvent which has a density of 1 gram per ml. So 1000 ml will be 1000 gram because density of water is 1. It is only valid for water, not for all, because water has density 1, that I have already told you. Density of water is 1 gram per ml. So ultimately we have to find x2. So x2 will be equal to n2, which is 1 upon 1 plus 1000 upon 18. So if you'll solve it, I hope few of the students has given the right answer. So chalo, perfect. Moving to the next one. Now take out your pen and copy. Let us finish 3 more definitions, basic definitions. So next concentration term is strength of a solution. Strength of a solution. Acha. We confuse. Sanjay is saying, sir, we confuse, sir. What is the confusion, Sanjay? Sir, how poll is open in PW app? Gayatri, I already told you, beta, if at all those polls are not working, then just after the class, go to PW app. In the chat section, you can obviously contact to the technical team. They'll be helping you with the options. Hana? They'll be helping you with the all the technical backlogs that you will be having. Kindly report it. You will be getting within 24 hours. You will be getting call from the tech team. Don't worry. Sanjay, what is your confusion, beta? Okay, so for remaining students, please write in conversion. Okay, beta, see what I have converted in this question. Let me again go back to this one for just a second. See, in this question, they have just given 1000 gram of water. 1000 gram of water, but in 1000 gram of water, you have to calculate weight, number of moles of solute. So number of moles of water, because which is acting as a solvent over here. So number of moles of water, which is solvent, will be equal to weight of water in grams upon molar mass of water. Weight of water given is 100 gram. Is 1000 gram. Molar mass of water is 18. We'll put it and we'll get the answer. So mole fraction will be equal to 0.0177. Now this is just mathematics here. We have no chemistry. Now the point that I was making over here is, if in this question instead of 1000 gram 1000 ml will be given, I was saying still you will be having the same answer. Why? Because density. What is the basic formula of density? Density of any substance is equal to mass of that substance upon volume of that substance. So mass is equal to volume into density. Therefore, density is equal to mass upon volume. It is for water, it is always valid. What is always valid? That for water, not for all. For water, density is 1 gram per ml. So if density of water is 1 gram per ml, and if instead of weight, volume of water was given, so if volume given is 1000 ml, then can you calculate weight of water in gram? Yes, sir. It will be ml gone. So it will be 1000 gram. So that is what I'm saying. For water, density is 1. Therefore, 1 ml of water is 1 gram of water. 100 ml of water is 100 gram of water, but not for any other substance, because it will depend upon the value of this density. And it is not your problem, beta. Most of the students find this confusion with the idea of density. So I hope we are clear with density now. Chalo. How can start poll? Beta, only I can start poll. No, you can't start poll. So once I start poll, you can definitely put in the answer that you have calculated using the PW app. Any of the student who are facing problem using the app, so please after the class go to the technical team, go to the PW app. In the chat section, you can directly report the query and you will be answered within 24 hours. Don't worry. Moving to the next concentration term, strength of solution. Please write this, beta. Now, strength of solution is nothing but very important. Now, here I'm saying your memory is going to help you like anything. So these definitions are not important. They are very, 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 very important. So please write them beautifully in your copy. How to define strength of a solution? Weight of solute upon volume of solution. So in symbol, what I'll be saying, strength we'll be representing as capital S. It will be equal to weight of solute, so W2, and I am being specific that you have to put in the definition, you have to put weight of solute in what unit? In grams. It is not up to you. It is defined. Weight of solute in gram upon volume of solution in liters. I hope everybody is clear with this. Written. Beta, Ritvik, weightage of this chapter is in advance. You get at least one question. In mains, you get at least one or maybe two question, and in CBSE board, you get at least 5 to 7 marks of question from this. So very important chapter and very doable chapter also. The basic, the beautiful chapter of physical chemistry, a very easy chapter, but yes, easy as in once you are giving your 100% in the classes and revising it properly, this chapter is definitely going to be giving you marks in your in any of your examination. So really important chapter. I hope everybody has written these definition. Can I move forward, guys? Chalo. Ritvik, I hope I answered. Chalo. Moving to the next definition. This definition most of you will be remembering from class 11th. So let us again revise it. The very famous concentration term, which is molarity. So molarity of a solution is represented as capital M, and molarity is defined as number of moles of solute. Kindly start writing it with me. Number of moles of solute upon volume of solution in liters. Kindly iterate it by your own words so that your own voice can go to your ears. Repeat with me. Molarity of a solution is equal to number of moles of solute upon volume of solution in liter. Strength was weight of solute. In the numerator, we had weight of solute. Here, in the numerator, we are having number of moles of solute. That means number of moles of solute is N2 upon volume of solution in liters. Or I can say molarity is equal to, if I replace number of moles of solute in the question, weight of solute is given. So weight of solute in gram upon molar mass of solute into volume of solution. But sometimes the volume of solution in the question is given in ml, but sir, definition is asking us to keep in liters, and we should definitely know 1 liter is nothing but 1000 ml. So if we are putting volume in ml, then we have to divide this volume with 1000 so that it can be converted into liters. So that 1000 will come in the numerator. So this becomes the beautiful formula which you will be using I don't know how many number of times. So kindly make note of this also. Very important. Now let us relate molarity and strength. Sir, weight of solute upon volume of solution in liters, which is this. Sir, this we have defined as strength. So that means I can also say molarity is equal to, this is strength of solution, so capital S upon molar mass of solute. So let me use that molar mass of solute with different pen. So this lands up with another conclusion. I don't want you to learn all these conclusions, but just interrelations, because your competitive examination loves these interpretations. So what is M and M2? Beta, capital M we use for molarity. I hope you can see. Molarity of a solution is represented as capital M, and MM as in molar mass. MM as in molar mass. So for molar mass, I'll be writing MM, and 2 as a solute, 1 as in solvent. I hope colic Mondal, we are clear beta. Not M2, MM. MM we use for molar mass. 2 is for solute, 1 is for solvent. Did you give homework at end of class? Beta, did. I will be doing it. So that is not a past tense. Yes, I will be giving homework in these slides. We'll be having questions which will be a homework. But post the conclusion of the class, you will be given DPPs also. Those DPP beta, I am making so much of efforts in selecting all the questions. So please attempt those DPP very properly. Please attempt all these. Please complete your class notes also very properly. And in the class notes, I'll be giving you some homework questions also. So everyday job you have to continuously doing beta, and that will only make the difference. Chalo, moving forward. I hope we are clear with this. Now, moving to the unit of molarity, because it's a very famous concentration term, highly used by industries also. So what is the unit, sir? How? Very easy. What is numerator? Number of moles. So unit of molarity will be in the numerator. I'll be having moles, and in the denominator, sir, volume. But in what unit? Liter. So this is moles per liter. But sometimes this is also referred as molar. So sometimes in the word problem you may also find 2 molar, 3 molar, 4 molar. That means moles per liter. It's the unit of molarity. I hope. DPP you will be definitely be given, Geeta, and that DPP is going to make the difference between you as a 99 percentiler, and if not attempted, then you as not getting that 99 percentiler. So attempting those DPP is actually very crucial. Acha, what is mean by DPP? DPP is beta daily practice paper, daily practice problems. Okay, chalo. Done till this point. Now, moving to the last concentration terms for this class. We'll be having some more concentration terms, but those concentration terms I'll be introducing in the next class. For this class, this is my last concentration term, and after that we'll be dealing with problems, with questions. Now, last concentration term is molality, and molality is represented as small m. Yashwit is saying, sir, what is S? Beta, kindly move your copy. Capital S we have defined as strength of solution. So that is what I'm saying, beta. Whatever you have written, please you have to read those copy. Ultimately, if you have written those things properly, although you have to revise it 2-3 times, but ultimately you will get this thing in your head. There is something else we have written. So kindly move your page just one page back. It will be written strength. I hope Yashwit, you got that S now. Sir, can I access the DPP? Yes, beta. Everybody can access the DPP if you have applied for, if you have paid for this Lakshya Jee batch, then definitely post the class. It will be there in your home page only. You have to go. I mean, I've already made a video. It will be posted to you, which will be helping you to actually access your DPPs that is posted in your portal, in your PW app. है ना? Okay, chalo. Moving to the next concentration term, which is molality. So molality we represent as capital M. Time to define molality. Molality is nothing but molality small m. I'm sorry, here it is printed as capital M. Molality small m. Its definition is number of moles of solute, again in the numerator, but denominator is having not volume, weight, not of solution, of solvent. So weight of solvent in kg. So you can obviously write this as number of moles of solute upon weight of solvent, as in W1 in kg. If this W1 is given in grams, so in order to convert into kg, you have to divide by 1000. So that 1000 will come in the numerator, just like molarity. And this number of moles of solute can be written as weight of solute upon molar mass of solute. So this is your formula. I'm just updating this formula because I again see some. This is weight of solute in gram, and this is molar mass of solute. I hope everybody is clear with this. Weight of solute in gram upon molar mass of solute is number of moles of solute. Weight of solvent if placed in gram. So in order to convert it into kg, I have to divide by 1000. That 1000 will come in the numerator. Siddharth, I have corrected the unit beta. I hope you can see that. This is in gram. Now, what is the unit of molality? Unit of molality is molal or moles per kg. This is molal, L-A-L, molal, molal. keeping oneself hydrated is also important, which we tend to forget during long study hours. Yes, that's why I'm making Prato Das. That's why I am drinking this water in a glass, so that you may also keep sipping water during the class, so that your attention is always there in the class, not going anywhere else. So I hope everybody has written the definition of molality. I had 2 glasses of water. Chalo beta. Moving forward. Moving forward. Now, next point is a very beautiful point, much loved by NTA. I hope everybody has written till here. Now, repeat after me. Repeat after me. Molality of a solution is equal to number of moles of solute upon weight of solvent in kg. Molarity, which is capital M, is equal to number of moles of solute upon volume of solution in liters. I hope everybody is comfortable with the definition. Now, units also, that is molar, this is molal. Molarity is capital M, molality is small m. I hope we are clear with the symbols and definitions. Now, sir, is water a universal solvent? Balaji is asking. Yes, beta, water is a universal solvent. Ridhisha, mass and weight are same in chemistry. Mass and weight are same in chemistry. We do not have any problem with that acceleration due to gravity. So mass and weight is same for us. So please tell me difference between molarity and molality in order to remember easily. Gayatri, that is what I'm doing. I want you to shout out with me. So give me a shout out, not in the comment section, but shout out inside your room. Repeat after me. Molarity, capital M, perfect, is equal to number of moles of solute upon volume of solution in liters. So I hope you have given a shout out, beta. Chalo. Moving to molality, which is small m, number of moles of solute, shout out. That is what I'm doing. Kaushal. Number of moles of solute, Kaushal, numerator, perfect, upon weight of solvent in kg. I hope everybody have shouted in your respective rooms, and once you do that, then only you will be remembering the definition, because that's a definition. So that you have to remember. Now, moving to which you must be seeing over here, moving to the point that some people can say, sir, why you are making us learn 2 definitions? Because scientists has made us learn 2 definitions. Why? So among capital M and small m, as in capital M is what, guys? Please shout out in your room. Molarity. Small m is what, guys? Shout out. Molality. Okay. So among capital M and small m, which is a better concentration term? So actually small m is a better concentration term. Now why? Suppose we are putting a sticker of concentration term on our solution. Suppose, let's say we are putting that sticker on a month of December. It is cold outside. It is really very chilling cold outside. So in such cases, beta, in such cases, when temperature is very less, we know that volume is highly temperature dependent. And because volume is highly temperature dependent, so all the concentration terms which has volume factor in their definition will also change with temperature. And therefore, small m, which is molarity, is a better concentration term as it is independent of temperature change. And why it is independent of temperature change? Because it is only because m has no volume factor. And we definitely know volume changes with change in temperature. What is the general change in volume? Sir, as temperature increases, volume also increase. And therefore, as temperature increases, volume increases, because volume is there in the denominator in the definition of molarity. So as temperature increases, molarity decrease. I hope everybody is clear with this. I'm again repeating it. All the concentration terms, now first you have to remember that their definitions. Now all the concentration terms which has volume factor in their definition, like molarity has volume of solution in the denominator, that volume will change as temperature will change. And because volume changes with temperature, so the concentration term will also change with temperature. And because small m, which is molality, has no volume term in it, it only has mass terms in their definition. And generally mass has negligible effect. If you ask generally, so we'll say mass is independent. Although if you go quite technically into it, then you can say mass changes with temperature, but very slight change. And if you compare that change with volume change, mass change is negligible. So actually, the bottom line is volume increases as temperature increase. So as volume increase, so denominator will rise in the term of molarity. So as a temperature increase, volume increase, so molarity will decrease. So because molarity changes with temperature, therefore it is not considered as a better concentration term, while molality do not having any volume factor in its definition, therefore it is considered as a better concentration term. Ankit, I hope, yeah. So I mean, beta, I am deliberately not using any Charles law type of thing over here, because Charles law is actually a law for gases, and here we are talking for liquids. I'm just speaking in general. Have you seen the lakes outside your city or maybe town? Sir, in summers we don't see even water in those lakes. The water is evaporated. That means when temperature is increasing, volume of water is changing from liquid to gas, evaporating. So it is requiring larger volume at higher temperature. So that is a liquid water. But when it is getting evaporated, that means it is requiring larger volume at higher temperature. But that is not Charles law, because Charles law is only valid for gases. But this temperature dependence with volume is in general also applicable. So I'm not using any of those misconceptions, because water is not a liquid, is not a gas, na? But yes, it is a very common sense which you can obviously feel. Again, an idea which you can feel. I hope everybody is clear with this. Chalo. Sir, explain formula once again. Kushal, I already explained it twice, beta. I'm doing it for the third time. Molarity has volume term in the denominator, and volume changes with temperature. Volume increases as temperature increase. So as temperature increase, volume as in denominator will increase in case of molarity. So denominator increase, therefore the ratio, which is molarity, will fall. So molarity decreases with temperature increase, and vice versa. But I'm not even asking you to learn everything, but at least understand the idea. And the idea is all the concentration terms which have volume in their definition, they change with temperature change. Because molality has no volume term, it only has mass term, and mass has practically no effect of change of temperature. Hence, molality will not change as temperature change. Molality as in small m will not change as temperature change. Therefore, it is considered as a better concentration term, because now you do not have to remove those stickers from the concentration term, from the reagent bottles. Let's say you are working as a lab attendant in a laboratory. You are putting stickers in the month of December. Now again in the month of May, you have to replace those stickers because the concentration terms has changed. Now you will say, "Arey yaar, I have done that job 6 months back. I have to repeat it." So rather, next year what you'll try to do is you put stickers of molality, so that even it is November, even it is December, even it is May, the value of molality will not change, but yes, molarity will change. I hope everybody is clear with it. Chalo. Now moving to the actual area, beta. Now this The complete class was just to make you revise the question, the formulas, because these formulas you must have seen in class 11th also. Now coming to my main point of discussion. So I want your full attention from now. I want your complete attention from now. Question number 1. I want everybody to take out your rough copy. Now I don't want you to do and attempt them in fair copy. Take out your rough copies. You'll be getting whole of these lecture notes, but I want your rough copy because I want your complete attention now. I don't want you to write what I'm writing. I want you to just take your fair copy with the definitions and attempt these questions on a rough copy with me. Make the fair copy, write these complete questions, but after the class. That will also force you to reattempt all these questions. I hope I'm clear with this. I need yes, yes, yes for the statement which I've just now made. I don't want you to attempt these questions in your fair copy. Put yes, yes, yes in the comment section so that I may know we are in sync with each other. Okay, guys. 4.5, sir. Chalo, perfect. Okay, guys. Students, yes, perfect. Chalo, attempt this question. Because we'll now be only focusing on attempting the questions, not making notes. Take your fair copy and use your fair copy only to see the formula, nothing else. Calculation, do not even write the question, just try to write the given data and attempt and do the calculations. Rough copy, not fair copy. Chalo. So we have few students answering 18 molar, 0.015. Chalo. Let us attempt it. Now, pens down, put your pen down and listen to me properly. Listen to me the very first time, because that is what I've done. Point 1, colic, perfect. I mean, whatever answer you're getting, let it be perfect, but we have a lot of participation. So good, guys, very good. First job is to write the given data. Find the molarity as in capital M, of the solution in which 9 gram of glucose is dissolved in 500 ml of solution. So 500 ml of not water or not any solvent, 500 ml of solution. So this 500 is nothing but volume of solution. I hope everybody is clear with it. This 9 gram of glucose, so this 9 gram is nothing but weight of solute in gram, and we have to find molarity. So sir, this is very easy. Molarity is equal to, I want everybody to repeat with me, number of moles of solute upon volume of solution in liters. But in the question, because it is given in ml, so I will use 1000 in the numerator, which will convert my volume into liters. But sir, here weight is not given, so no worries. Instead of weight of solute, I'll be writing number of moles of solute. I'll be writing weight of solute upon molar mass of solute into volume of solution in ml. I am deliberately writing the complete formula because I want you to remember this formula by heart. So for those who are getting the correct answer, I'm proud of you, friends. But for those who are not getting the answer, please make sure you are writing it. I'm not focusing on you writing this in your fair copy. Maybe do not write it, but at least be with me and you will be completing your copy later. So what is weight of solute given? 9 grams into 1000. What is molar mass of solute? Now that is the only chemistry task that we have. So glucose is C6 H12O6. Some of the times, 90% of the times, question is also given with provided with the molar mass of solute, but sometimes it is not. So you can obviously calculate 6 into 12, which is for carbon, 12 into 1, which is for hydrogen, and 6 into 16, which is for oxygen. If you add, you will get 180 gram into volume of solution is given out to be 500. So if you solve it, now this is a task which will be requiring your practice. So that is why I'm saying I am not asking you to write this in your fair copy. Just practice in your rough copy. Do not even write the question, and once the class is done, then you will do it. I hope everybody is clear with the concept. I hope everybody is clear with the idea of just using the basic question. Chalo, perfect. So Shivika, perfect. Everybody is answering 0.1. Moving forward. Let us try. Okay. Let us try and attempt this question. The question says, find out the molarity as in capital M, of 165 gram glucose. You also keep on doing it. I am also doing it. 165 gram of glucose. So this is weight of solute. This is glucose. So molar mass of solute we have already calculated. It is 180 gram. Find out molarity of 160 gram glucose solution. Density is given. So this density, now read the question. This density is of what? Sir, this density is of what? This density is of solution. How you have iterated that? Sir, just read the question. After solution in the bracket, they have mentioned density. That means this is the density of the solution. I hope everybody is clear. Now, density of the solution is given out to be 1.1 gram per ml, in which glucose is 20 gram. So this is find out molarity of 165 gram glucose solution. Okay. So again, I am reading the question again for you, because the question is tricking us with word problem. Now what is the word problem? Read the question very properly. Find out molarity as in capital M we have to calculate of 165 gram glucose solution. So actually you are given glucose solution, not glucose solution. So that means this is the weight of solution. So weight of solution given is 165 gram. Sir, what is solution? Remember, solution is mixture of solute and solvent. And density of solution is given out to be 1.1 gram per ml, in which glucose is 20 grams. So actually weight of solute is 20 grams. I hope everybody is clear with this. Sir, but we do not have any formula. We do not even require any formula. We require our common sense. What is the common sense? Common sense is, sir, weight of solution is nothing but weight of solvent plus weight of solute, which is given out to be 165 gram. Sir, weight of solute we already know, which is 20 gram. So weight of solute, which is 20 gram. So ultimately for molarity, what I need number of moles of solute and I need volume of solution. Let's say this volume I am getting in ml, so I will multiply 1000 in the numerator. So ultimately, how can I find number of moles of solute in 165 gram of solution? I have this bucket in which I have solution and the weight of solution is given out to me. This solution is 165 gram. Sir, but this solution has water also, and this solution has glucose also, and it must be a homogeneous solution. Let's say this is my glucose and this yellow portion is my water. I am given with weight of both of them and I have to determine molarity of the solution. For molarity of this bucket, I need how much number of moles of glucose are present, which I can clearly calculate. How? Because it is saying 20 gram. So weight number of, can I calculate number of moles of solute? Yes, sir. 20 gram of solute. So upon molar mass of solute, what is molar mass of glucose? Sir, for glucose, I already have calculated it is 180 gram from the previous question. If for this question it is not given, you have to calculate. So this is 180. So number of moles of solute is nothing but 1 by 9 moles. I hope everybody is clear that we know N2 now. So N2 is 1 by 9. So this is 1 by 9 into 1000 upon. What else I need? I need volume of solution, but I only know weight of solution. So what will be volume of solution? Sir, mass equals volume into density. So volume equals mass upon density. What is the mass given? Sir, 165 gram. What is the density of solution given? Sir, 1.1. So 1.1 gram per ml. So volume will be coming out directly in ml. So this is my volume as in 165 upon 1.1. Done. Now you just have to do mathematics over here, and I hope everybody will get the answer. So somebody, Gayatri is saying 16 by 8. So let me do quick calculate, guys. Calculate this for me. Calculate this for me. So that 1.1 will go to the numerator. So 1.1 into 1000 will be 1100 upon 9 into 165. So now you have to do it by yourself, because obviously you will be getting integer type questions of this sort. So this will be somewhere around 0.741. Yeah, because sometimes if an integer type question is coming, like they ask molarity is dash into 10 raised to the power minus 2. So your answer will be 74. I hope everybody is clear. Yeah, perfect. I hope now we are making sense that why I have given those definitions first, and now I'm making you revise those definitions. How? Go to your rough copy, attempt these questions in your rough copy, and do not try to duplicate these explanations, beta. Solve it by yourself in your rough copy. And once you are again doing it in your fair copy, I am telling you each and every concept will be yours. But for now, open your fair copy for seeing those definitions, for seeing those formulas, and attempt with me in your rough copy. Do not have a habit of writing all of the content which I have written over here, because that will make you a line follower. Rather solve by yourself. Whatever mistakes you do, please commit those mistakes right now, so that you will not be repeating those mistakes in the D-Day, in the main examination. I hope I'm making sense. Perfect. We are getting so many answers. Perfect, guys. Chalo. Moving to the next question. Next is the calculate the molarity. Now this is the same questions, and hence this is a homework for you. This is the same question. Although you can ask any of these questions in the next class, but here this is a homework for you. You have to again calculate capital M molarity, 30 gram of this solute whose molar mass is given in, this is my volume of solution. So I hope you can very well calculate this. For all those, sir, how will we check our answer? Once you will get this PDF, the answers will be here. Just you have to check the bottom right section, you will be getting your answers also. So I hope I am giving you a right format of practicing questions also. Moving to the next one. Now, sir, okay, that means what else we should know? After calculating molarity, although what I'm doing over here, this mixture we'll be doing later. This mixture we'll be doing later, because I want you to deal with some concentration terms first. Solve this question with me, guys. I want answer to this question. Beta, Rida, that's what I've done, because I want to rush to interconvergence of concentration terms. So I have few questions we'll be practicing tomorrow in the tomorrow's class, because today I want you to apply all those topics first. The topic, the definitions that we have written, I want you to revise those definitions first. So that's why what I'm doing is we are directly jumping to JEE mains level of questions, so that you may have a confidence also. So as as your some of the students are saying poll, Michelle is saying poll, so even I want you to have that confidence. We have started from zero and we have directly jumped to JEE mains level of question. So let us attempt this question, guys, and because it's a demand, so I am giving you 30 seconds for this question, this which is a JEE mains 2022 question. Please answer, guys. Sir, the batch is for class 11th or 12th. It is for class 12th, beta. Solution and colligative properties. Chalo. Perfect, guys. We have few answers also. Chalo. We are saying few of the students are saying 0.2. Ekaf, don't worry, Michelle. Don't worry, beta. Few of the students are saying lecture got ended in app. Let me check. Nahi, beta. The app is working fine. App is working fine. Chalo. So time is over. Option A, let's say, is the right answer. Oh, 50% of us are right. Yeah. Naren has given the answer as the topper, and I guess yes, most of us are correct. So Naren, good. Chalo. The question says now, put down your pen and copy. You do not have to write whatever I'm writing. You have to understand what I'm teaching. So put down your pen and copy and listen to me. 518 gram of an aqueous solution containing 18 gram of glucose. Molecular weight is given. What is the molality of the solution? Now 518 gram is weight of aqueous solution. So weight of solution is given out to be 518 gram. 18 gram of glucose. So weight of solute is 18 gram. So what we have to calculate, sir? We have to calculate molality as in small m. Definition of molality, everybody repeat after me. Number of moles of solute upon weight of solvent in kg, or number of moles of solute can be written as weight of solute in gram upon molar mass of solute into weight of solvent. If I'm using in gram, I have to multiply 1000 in the numerator. Now let us see what all values we have. Sir, we have weight of solute, so this is done. Sir, we have molar mass of solute, so this is done. Sir, we have 1000, so this is done. What I only require is this W1. This is the only thing I require. Sir, weight of solvent. Sir, solution weight is given. Solution is nothing but weight of solvent plus weight of solute. The summation is given out to be 518. So W2 is given out to be 18. So W1 will be 518 minus 18. Oh my god. So this is class 10th. Put that 500 over there and you will get your answer as 0.1. I hope everybody is done with this. Sir, can I watch this class later? The recorded class are available. Yes, beta, you can definitely watch this later. But doing this in live class will help you to have an examination feeling as well. But yes, if you have some other related obligations, then you can obviously watch the recorded versions. But I will always recommend to do the class in the live session. because after the live session you will be having the job of writing the questions also properly and of re-attempting the question. So at least attempt it the very first time. But yes, you must be having some serious obligations. So obviously if you do have, so then you can obviously proceed. You will be getting the recording, don't worry. Moving to the next question. So again, I'm starting the poll. I hope everybody has done the previous question. Now I'm just giving 30 seconds. Guys, you may feel, sir, I need more time. I definitely know you will feel I need more time, and I know this will take more time, but at least I want you to have a look at the question properly. Just have a look at the question properly. That's it. Just try to write down the data, whatever is given to you. Just write the relevant data. What are the given data? Few of the educators do this. They derive some formulas and they ask student to read to learn those formula. I am not asking you to learn those formula. Do it with common sense, and we'll be doing it with common sense. Okay, so I hope poll has stopped. Okay, we still have 70% students answering this. Perfect, guys. Perfect. Very good. Let us attempt this question also. For those students who have not been able to attempt it, don't worry. Bilal, perfect. Don't worry. But put down your pen and copy right now and listen to me properly. You can obviously do the scanning later, but here practice on whatever I am saying. Moving to the question. The question says density of 3 molar NaCl solution is 1.25 gram per ml. And you have to find molality. Although in my next class, that is tomorrow, we'll be deriving some relationships, because those relationships also mains ask. But that will be doing tomorrow. Today what are we planning to do? We are going to do basics, because what we know till now is basics. So let us do that basic, and basic is those definitions. So that fair copy is definitely open in front of your screen, in front of your eyes, in back at your place. You tell me what is the definition of molarity, because molarity of the solution is given and you are asked small m. Definition of molarity is moles of solute present in volume of solution. Can you have this idea? Let's say I have this bucket of solution. Now in this bucket of solution, let's say it's a huge bucket. Let's say this huge bucket of mango shake is there. I have taken 1 jug of mango shake. Now you just taste mango shake from this jug or bottle, or you taste the mango shake from this bucket, huge bucket. Sir, they will both taste the same. Now what you do, you just take out a glass full of mango shake from this huge bucket. Sir, all 3 of them will have same concentration. That means all 3 of them will have same concentration. So all concentration terms will also be same. So actually concentration terms are independent of amount, or rather volume taken, because concentration terms are ratios. I hope we are in synchronization with this fact. Now let's say for this whole concentration, whatever will be the molarity, it will, and whatever will be the value of capital M and small m, this will also have the same value of capital M and small m. This will also have the same value of capital M and small m. So my point is molarity and molality of this huge bucket and molality of mango shake in this glass, sir, will be same, because the taste is same. The rasna that is there in the huge bucket, what do? You put a spoon and you taste that mango shake. Tasting good? You take out a glass from this huge bucket and now take a spoon of mango shake. Sir, both mango shake will taste the same. That means concentration is same. So whatever is the value of molarity of this huge bucket, molarity value will remain the same even I have taken a glass of mango shake from this huge bucket. I hope everybody is clear with this. I want number of yes over there. I hope everybody is clear with this. Guys. Chalo. I hope everybody is clear with this. Chalo. Now, if you know, if you are understanding and if you are in sync with me till this point, then I am going to do this question in a common sense way. Because the question is saying molarity is 3, so can I say this means I have 3 moles of solute dissolved in 1 liter of solution. Why? Because I am killing one variable. What is the variable? Volume. Definition of molarity is number of moles of solute upon volume of solution. So actually, after taking 1 liter, I am killing the denominator, which is volume of solution, because I am allowed to take any volume which I feel comfortable with. So mathematically, I am comfortable with what? 1. Why? Because definition of molarity is what? Moles of solute upon volume of solution in liters. So rather, I am killing this denominator. How I am killing it? I am taking this denominator as 1 liter. But now I will be doing whole of my calculation in this volume only. Like for example, if I have focused on this small jar, so this will have corresponding weight of mango shake. So number of moles of solute I'll be calculating in this. Number of moles of solvent I'll be calculating in this. So all calculation I'll be doing for this particular glass. And what glass I have picked? I have picked a glass having 1 liter of solution. What is the advantage? I have killed one variable. So ultimately, if this is the case, then volume of solution is fixed. This becomes my volume of solution. And 1 liter of solution is having N2. So number of moles of solute is also fixed. Now the question is done. Why? Because you have to calculate molality of the same solution. So molality will be equal to number of moles of solute, which I already know. I just need to find weight of solvent. Let's say I'm using it in grams, so I'll use 1000 in the numerator. So ultimately my only task remaining is calculating weight of solvent. So this is the same question. How to calculate this? Now I know volume of solution. Can I get weight of solution? Yes. How? Density of the solution is given. Now density of the solution is given out to be 1.25 gram per ml. So if I multiply volume in ml, can this density multiplied by volume will become mass? Yes, sir. So this will be my mass of solution. It is multiplied by density of solution and volume of solution. What is the volume of solution I have taken? So 1000 ml. 1 liter is 1000 ml. So 1000 ml into 1.25 gram per ml, ml gone. So mass of solution will be nothing but 1250 gram. I hope everybody is clear with this. So please, beta, I'm in the process of explaining this. I'm again telling you. Because molarity is given out to be 3. So by definition, can I say 3 moles of solute is dissolved in 1 liter solution? Yes. What is the volume of solution? Now I am focusing on 1 liter of solution. So can I calculate mass of 1 liter solution? Yes, because density of the solution is given. So mass equals volume into density. Density into volume. Volume is 1 liter as in 1000 ml. So 1000 into 1.25 is 1250 grams. So this is my weight of solution. Now can I calculate, because I know weight of solution, so can I write weight of solution as 1.1250 gram, and weight of solution is nothing but weight of solvent plus weight of solute, which is 1250, which we have already done in the previous question. Weight of solvent I need because I need to calculate molality. I just require weight of solute. And do I know what is number of moles of solute? Yes. So can I calculate weight of solute? Yes. Because weight of solute will be equal to moles of solute into molar mass of solute, which is glucose. How many moles of solute I have? 3. What is molar mass of what is my solute? Okay, here solute is NaCl, not glucose. I'm sorry, I beg your pardon. Here solute is NaCl. So molar mass of NaCl is 23 plus 35.5 as in 58.5. 23 plus 35.5 as in 58.5 is molar mass of solute. Sometimes it will be given in the question only, so do not worry with that also. But can you calculate now weight of solute? Yes sir. Number of moles of solute, so W1 will be equal to, let me first calculate W2. So number of moles is 3 into molar mass is 58.5. This is equals to 1250. So this W1 will be equal to 1250 minus, this is 63 is 60 into 3 is 180. 180 minus 1.5 3 times, so 4.5. So this is 175.5. Just check. I guess you will be getting weight of solvent. Perfect, Michelle. So once you solve this, you will get W1. Once you put W1 over here, and now into divide I'm keeping on your part. Once you calculate that, you will be getting molality as 2.79. You can obviously approximate it also, because ultimately I will be having 3000 in the numerator, and this will be 1250 minus, so this will be obviously more than 1000. So 3000 divided by more than 1000, so it will be definitely less than 3. So what option is less than 3? Only one option is less than 3. I mean slightly less than 3. This is very much less than 3. This is also very much less than 3. Slightly less than 3 is only this one. I mean obviously you can solve also, but what point I'm trying to make is this is a question from JEE Mains but asked by JEE Advanced also. So I hope everybody is clear with this. Guys, good morning Ayush. Chalo, perfect. Haan beta. Ankit, I am using one more question, because I'll be taking such questions tomorrow also. The reason I'm doing this question today in the first class only, because I want you to at least spend a night with these questions as your homework questions, which you will be doing in your fair copy. We'll be doing such questions in the coming 2 classes, tomorrow also, day after tomorrow also. I mean whenever we'll be having a third chemistry class, we'll be practicing such questions for the coming 3 classes. Don't worry, we'll be repeating it so many number of times. The only reason I have given you all the definitions in the beginning is because of the same fact, because not you, most of the students face this problem. And the problem is they do not remember the definition. So how I plan to make you revise the definition, because now you will be opening those pages where you have written those definitions again and again. And I am telling you, within a frame of my 3 lectures, these calculations, these application of concentration term, which is actually a many of the students are fearful of these concentration terms calculation. I am very sure after the 3 classes you won't be. So that's why I've given all the definitions in this class only. Yes, there are some more definitions of concentration term, but that I'll be giving in the 3rd lecture of the concentration term. So I hope we are clear. All the students who are asking, sir, one more, I hope you got my point. Why I'm not doing it one more, because first I want you to at least revise it, and then when you'll come tomorrow, we'll be doing the same level of questions, but then you'll be gaining the confidence. So this class is introducing the concept. Next class is the smoothness and simultaneous application of the definitions that we have read. I hope we are clear with this. Chalo, one last question, guys. Okay, so because I'm saying one last question, all these questions are homework for you guys. This is also a homework for you. This is also a homework for you, although this is an advanced question, but I am giving you as homework. I guess few of you will be able to do it. Okay. So this is the question. This is also an advanced question. Let us attempt this one. Let us attempt this one. Chalo. Last question. Give it everything. Give it everything. I want you to attempt this right now. Rama Gaurav. Give it your everything. I am also giving it my everything. How? I've got 2 bottles. One is gone. I mean, this is the second one. One is already gone. So this is my everything, my last glass of water, and then we'll be finishing. By the way, I loved the first class beta. You guys are responding very actively. I'm very happy. I'm very happy with all the responses that we are having today. I'm super excited for the remaining for the classes, following classes. I hope you are too. But in order to be super excited, please complete your lecture notes very properly, very properly. Although these notes are having whatever format you will be getting, I'll be only giving you those questions which I have marked as homework. Remaining questions we'll be taking in the next class, because don't worry, we'll be practicing such questions for the coming 2 lectures. So don't worry. है ना? चलो. That will be enough. So the question says, let me directly help you with reading the question. Beta, I'm E.G. I don't know how to pronounce that name. Ige Mauk Thika. I'm sorry if I'm pronouncing it inappropriately, beta. I'm explaining that again. What I was telling is, beta, x means mole fraction. Michelle, x mean x means mole fraction. Beta, whatever we have done in the definition part, at least that much you should know, na? X means mole fraction. Chi means mole fraction. Now, the student who is saying, sir, please repeat. Should I take notes? So, beta, this is enough. This is more than enough. Don't worry. This is more than enough. Don't worry. Okay. So we Akshita is answering also. So beta, let me check. The answer is beta 50 by 27. Whatever it is. Answer is 50 by 27. So because you are calculating, so let me help you with the calculation also. It is 50 upon 27. It is somewhere around 1.85 beta. Okay, no worries. I am focusing on the concept. Let us do the concept now. Chalo. Urea. Formula also given. Molecular weight also given. When dissolved in water has chi as in mole fraction of urea, that means mole fraction of solute is given out to be 1 upon 31. Now, most of the students, Ashlesh, perfect. Most of the students make a judgment of error in such questions. You know what is the judgment of error? Common sense. Do you remember one thing? In my previous question, what I've done? Whatever concentration volume you have, if I take 1 liter or 1 kg from that huge bucket, the amount that I have taken will have the same concentration term, remember? So kill the variables. Sir, how to kill variables in this question, sir? I'm good beta, do the definition. Sir, what is definition of mole fraction of solute? Mole fraction of solute is equal to number of moles of solute upon number of moles of solute plus number of moles of solvent. I hope you remember this. Now, N2 is given out to be 1. I am not saying, sir, it is a ratio. When I agree, but I am taking a bucket. Can you stop me to take this bucket? No. This bucket is having number of moles of solute as 1. Because N2 is 1. Whatever answer is given, whatever data is given, I will take that as number of moles of solute in my solution, not yours, my solution. And my solution will kill some variables. So what variable is killed? Sir, I do not have to worry about taking the ratio. Because if N2 is 1, if in my solution n2 is 1. So if this is 1, so that means this is definitely 30. Why? Because 1 upon 31. How it will become 31? 1 plus 30 will become 31. That means, sir, n1 is definitely 30. I'm not saying this ratio will always have n2 1 and n1 n2 1 as and n1 30. No. But sir, 1 upon 1 plus 30 is also 1 upon 31, na? Yes. So let me take this solution, and now I'll be calculating everything for this solution. What is asked for this solution? Small m. So molality will be equal to, I know formula, sir. Number of moles of solute upon weight of solvent, let's say in gram, therefore 1000. Sir, n2 I definitely know. So n2 is 1 into 1000. Sir, I just want weight of solvent. Sir, I know moles of solvent. What is moles of solvent? 30. Who is solvent? Urea when dissolved in water. Sir, solvent is water. So molar mass of solvent is 18 gram. So weight of solvent is, sir, weight is equal to moles into molar mass. So 30 into 18, because weight, let me write that weight separately for you. So weight of solvent is moles of solvent into molar mass of solvent. Done. Beta, done. I hope everybody is clear. So if you just solve it, I mean, we do not have to solve it completely. This is 100 upon, okay, why do 100 also? So this is 50 upon, this will become 9. 9 into 3 is 27. This is 50 upon 27. Yeah, perfect. 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 Siddharth, Michelle. So I hope everybody have got the answer. Now, I have a few more questions for you, but yes, those questions we'll be doing tomorrow. Because today I feel we have done appropriately, but you have to repeat and recollect all these questions in your fair copy very properly. Attempt the DPP that will be followed by this lecture, and we'll be meeting tomorrow, and tomorrow we'll be doing such questions again. So don't worry. Whatever doubts you will be facing over here, you will just put in those doubts in the comment section. I'll be discussing those questions again, and then we'll be discussing more questions around it. You can ask the DPP also tomorrow. Okay, beta? Chalo. So this is it. I had an awesome time in my first class, but I am saying to each and every one of you, all those students who have come, who have been able to reach out to us in the live comment section, I am asking all the YouTube guys also, beta, see the level of communication we are having over here. We are not flooded with any sort of comments in our class, so it will be highly interactive. We'll be practicing questions and discussing questions from this theory tomorrow. So all those of the YouTube side of people, because we'll be not meeting tomorrow, because we'll be only meeting inside the batch. So if you still want to join Lakshya Jee in English, so you can still, the price is still discounted, which I feel after tomorrow the price will again be getting increased. So make a conscious choice, join us, and let's crack that Jee together. Bye bye, good night, and take care.